Okay, in this video, I will demonstrate about PCPGUI in digital image processing. The first is the image negative. I will demonstrate how it's works. You could simply just add image first. Um, as you can see, I already input the image in the PCPGUI. Now I will demonstrate about the image negative. The output of the image will be a color which change to the negative colors of the original input. Okay, the second is I will demonstrate about the image rotate. For the image rotate, the 19 rotate, it will look like this, and 118 will look like this, and 270 is will look like this. Now I will be demonstrate about the translation image. You simply just input the x-axis and the y-axis. I will input like this. I will input two numbers, and the y-axis I will put in 4. As you can see, the part of the image output will be cropped. Okay, moving on the image flipping. On the flipping, the H, the H, V, and HV is for the H is for horizontal, the V is for vertical, and the for HV is for the horizontal vertical flipping. Okay, the first is horizontal. It will be so it look like this. For the vertical, it will be look like this. And for the horizontal vertical, it will be look like this. Okay, moving on the grayscale. Uh, I will include the photo look like this. Then I will be showing the image processing grayscale. It will be look like this. Okay. For adjust brightness, you just simply add number how much you wanna bright the for the adjust the bright for the image. I will try look like this. Um, maybe for the drag image, it will work clearly. As you can see, the change of the output image will be changed to white. Moving on the logarithmic contrast, it will be look like this. The darker, I think, for the more numbers. Okay, maybe look like this. For the adjust power law, it will be look like this. You must enter the gamma value. It will be showing the image look like this. Okay, moving on the threshold. The threshold will be, I just, the grayscale maybe look like this, the output of the image. And for the zoom out, I just add how much you want to zoom the output image later. I will try to add 10 numbers for the zoom out. Okay, for tens, it will be minimize the output image, and for the zoom in, it will be zoom in the output image. Just like this, I just want to add the number. Okay. For the zoom in, it maybe took a little bit time to processing for the output image. Okay. For the second time, I add some number. Okay, for the output image in the zoom in, it will be zoom the input image into this picture. Okay, for the last list, I will show you the blend processing image. Okay, for the blends, it will be combine the two of the input image from the input one image and the two input image. Okay, moving on the code, I will show you. Okay, for the first one is for the first is the for the function of the negative image processing. Okay, the first is the depth image negative. This sixth line, it means that this defines the image negative function, which takes two arguments, such as image input or image input image, and call depth is for image color depth. For the second line is if call depth, uh, this condition, which means if the color depth is not equal to 24, then the input image will be converted to the RGB color mode in order to process. The third line is for the create is for the create an output image with the RGB color mode and the same set as the input image, which will be used to store the result of the negative creation process. Moving on the line 9, it this means it the uh, um, this means is the create. Oh, this I already was explained that. Moving on the line 10, this means is the this loads the pixel of the output image into the pixel variable, which will be used to modify the image. Moving on the line 11, for I in range image output size, this will be iterated through each x coordinate in the output image. The next is the first loop, uh, the second loop. The second loop will be iterated through its y coordinate in the output image. In next is the line 13. This means is the this retrieves the color component value or RGB of the input image pixel at the position E, E and G. Moving on the visible black. Moving on the pixel this in the line 14 is for the this means it generates a negative value for its color component such as RGB by subtracting the value from 255. Moving on the pixel IG, this assigns negative value to the output image pixel at the position EG. Moving on, the last is for the conditional converts the output image to the operated color depth if necessary. For the last is the return image output. This means the function returns the output image that has been modified according to the negative creation process performed. Moving on the logarithm for the code rotate 19. Okay. The first is this defines the function of the image, which takes 4 arguments such as image input, called depth, and direction, and direction. The first is the if depth. This condition which means if the color depth is now equal to 44, the it will be converting to RGB color mode for processing. Next is the image output equals image new. This creates an output image with the rotation size, such as height and width swap, to accommodate the 1990-degree rotation result. Next is the pixel equals image output load. This loads the pixel from the output image into the pixel variable, which will be used to modify the image. Moving on the first for the loop is for I in range image output size. This means it will be iterated to its x coordinate in the output image. Next is the second for the loop is for G in range image output size 1. Will iterate through HI connection in the output image. The next conditional checks the next conditional checks in the direction of rotation is if the rotation direction is C or clockwise, then the pixel at position G image output size 1 minus I minus 1 of the input image will be moved to the pixel at position E and G in the output image. Note that in this process, the X and Y position in the output and output image are swapped, and the X position in the output image is calculated from the end to the beginning. If the rotation direction is CC or counterclockwise, then the pixel at position image input size 1 minus G minus 1 E of the input image will be moved to the pixel at the position image input size, move to the pixel at position E and G in the output image. In this case, there is also an exchange of X and Y position, but the calculation of the X position in the input image proceeds from the end to the beginning. The last question now is the convert the output image to the appropriate color depth if necessary. And the last is the returning microcode, the function return the output image that has been modified according to the 90-degree rotation process formula. Moving on the image rotate 180 is the same with the 90 code. I just modify a little bit in the for I in range image output size 0 for G in range image output size 1. Okay, these two loops are used to iterate through each pixel in the output image. The variable I represented the x coordinate or image y, and the variable g represented the y coordinate image height. The next, we look at the part that check the direction of rotation. If direction equals C, RGB in image input get pixel this. When direction is equals C or clockwise, the pixel of the input image are affected from the change position. The position of the retrieved pixel is input image weight -1 minus I minus 1, input image height minus G minus 1. In this case, we rectify the pixel from the input image in reverse, which is actually a 180-degree rotation effect. If the directs uh, if the directs counterclockwise, then the pixels are taken from the corresponding position in the input image without any change. After getting the pixel value, they are stored in the output image. The retrieved pixel values are then stored in the corresponding position in the output image, thus creating an image that has the rotation in the 180 degree, thus by using the change in the pixel position at the time of retrieving pixel value from the input image. The code successfully creates the effect of rotating the image by 180 degree. Moving on the image rotate 270. This code set the degree direction in the function is the part located inside the for loop that refers pixel value from the input image. The degree direction is determined by the variable direction. If direction clockwise, the image will be rotated by 270 degree. And if direction is counterclockwise, the image will be rotated by 90 degrees. In the line that said the degree direction is in if direction equals C, RGB image input get the pixel. Okay. Here is depending on the value of direction, that is if C or clockwise, the pixel of the input image will be retrieved from the change position, or counterclockwise according to the clockwise rotation direction. If counterclockwise, the pixel will be taken from the opposite or unrelated position in the input image, thus creating a 270-degree rotation effect. Okay, we moving on the translation image. Okay, the translation image function is to perform image translation, shift the image based on the shift along the x or horizontal and dy or vertical. The following is a line by line explanation of the code. Is the def translate image will be a def translate image input called def dx dy. This uh, this defines a translation image function that takes four arguments such as image input called def, dx, and dy. If you want to call depth, this condition, which means if the color depth is not equal to 24, then the input image will be converted to RGB color mode. Uh, I think I explain in this section now. This section is the this create an output image with the same size as the input image, which will be used to store the translation result. Moving on the pixel equals image output load. This loads the pixel of the output image into the variable named pixel, which will be used to modify the image. For the width height equals image input size, this gets the width and height of the input image. For I in range width, this is a loop that will iterate through each x coordinate in the input image. For G in range width, this is a for loop that will be iterate through its x coordinate in the input image. For G in range height, this next for loop that will iterate through its y coordinate in the input image. For new x equal I plus dx, this means m new y equals g plus dy. This calculates the new position of the pixel based on the shift or translation along the x and dy. Moving on, if 0, moving on this section in line 96, this ensures that the new position is within the boundary of the input image, so it does not exceed the image boundary. Moving on this section is mean this get the color of the pixel at the new position from the input image. Moving on this line, this means this set the color of the pixel at the position G in output image according to the color of the pixel at the new position of the input image. The next is the next coordination. The next is conditional. If call depth equals 1 and if call depth equals 8 and else are this to convert the output image into the color mode corresponding to call depth. And the last one is the function that returns the output image has been modified according to the desired translation. Okay, moving on the vertical flip. Moving on the flip vertical. In this line, moving on in this line, this means the create an output image with the same size as the input image, which will be used to store the vertical flip result. Moving on this line, this means this loads the pixel from the output image into a variable named pixel output, which will be used to modify the image. Moving on the row cost equals image sample size. This means this gets the number of the row and columns of the input image. Moving on, for the I in range row, this means is the for loop that will iterate through each row in the input image. And for the G in ring calls, this is a nested for loop that will iterate through each column in the input image. And moving on the code, this code, this means is this is the main part of the function. Here, the pixel from the input image to the output image will be performing a vertical flip. We use the formula calls a minus g a minus 1 to change the pixel position vertically. So the pixel in the remains unchanged. The remains unchanged as only the row are shifted vertically. Okay, moving on the flipping horizontal, same as the code in the vertical, I just modify in this section. This mean is this load the pixel from the output image into the variable name pixel output. No. This means is the to shift the uh, position using the formula row minus I minus 1 to get the position into the horizontal. Okay, moving on the uh, flipping horizontal vertical. I use the same code. I just change this code. This means is the input image to output image by doing horizontal vertical flipping. We use the formula row I minus 1 for the horizontal flip. I use calls minus 1, calls minus G minus 1 for vertical flip. So the pixel at the bottom right corner or the last column and the last row of the input image will be moved to the left corner, first column and the first row of the output image. Okay, moving on the processing grayscale. Uh, in this code, it will be this is a for loop that will iterate through its exponent in the output image. And for G in range, I make output size. This means is this is a nested for loop that will iterate through AI coordination in the output image. Moving on the bottom code, this uh, yeah, this is the operation to get the color component value, such as RGB of the input image pixel. If the color depth is 24 bits, we take the RGB value from the input pixel. If not, we assume the input pixel has only one color component and we replicate the value to get 3 equal color components. Okay, moving on the bottom. This is a formula to calculate the grayscale value from the color component value, such as RGB, using luminance conversion. The formula is a particular combination of the RGB values with a certain weight that adjusts the contribution level of each color component to the brightness of the pixel. Moving on this code, this means that set the grayscale value of the pixel at the position E, G in the output image. Okay, moving on the adjust brightness. For the adjust brightness, I use the in this code. Uh, in this code, this is a for a loop that will iterate through x coordinate in the input image, and for g in range high, this is a nested for loop that will iterate through hi coordinate in the input image. Moving on the RGB equals image input get pixel EG. This refers the RGB value of the pixel at the position EG in the input image. Moving on this code, this retrieves the RGB value of the pixel at the position EG in G. This code is to adjust the RG and B value by adding the given brightness factor. Yeah. Moving on this code, this means is to ensure the RGB value are within the valid range 0 to 25, 255. Moving on the pixel IG in this code, this will be added the pixel at the position EG in the output image with the adjust RGB value. Moving on the last conditional converts the output image to appropriate color depth. Okay. The next is the adjust contrast logarithmic. Okay. For the logarithmic, is the in this code. This means this reflects the color component value RGB of the input image pixel at the position E and G. This code means that this calculate a new value for the red color component R using logarithmic contrast formula. S equals C multiply log 1 plus R, where C is the contrast factor and R is the original value for component for the color component. Then the value is converted to an integer. Okay, for the this code, this means is this set a new value for the output image pixel at the position EG with the newly calculated color component values. Okay, moving on to the adjust contrast power law. Same with the logarithm. I just change the formula in this code. This retriever, this calculate a new value for the red color component R using the power law transformation. Using the formula S equals C multiply R gamma, where is C is the contrast factor, R is the normalized value of the color component in the range between 0 and 1, and gamma is the given the gamma value. Then the value is the convert to an integer and convert back to range 0 to 255. Okay, this set the this code is set a new value for the output image pixel and position EG with the newly calculated color component value. Okay, moving on the threshold. For the threshold, uh, in this code, this means that this create an output image with a grayscale color mode or L mode and the same size as the input image will be used to store the result of threshold process. This in this code, this is the conditional, which means if the color depth is not equal to 8, then the input image will be converted to a grayscale image. Okay. Uh, Image output. Moving on the this code. This code. Okay. This is the first loop that will be iterated through its coordinate in the output image, and this is for the second loop is the next loop that will iterate through its coordinate in the output image. Okay, moving on to this code. This is where the pixel value of the input image at the position EG. Moving on, this code is uh, the next conditional checks whether the pixel value exceeds the threshold value or not. If it exceeds, the pixel is set to value 255 or white. Otherwise, it's set to value 0 or black. Okay. Okay, moving on the scale. Moving on the blend image. Okay, for the blend image, in this code, it means the image input one is this convert the first image to RGBA or red, green, blue, alpha mode to allow the use the alpha channel. And same with this code, this means that convert the second image to RGBA mode in format conference. Okay. The next is the this code. This code is the adjust the size of the second image to match the size of the first image, so that it can blend whenever the size the first input image. Okay. The next code is this code. Uh, this means is to check whether the image input is a scalar or a single number or not. The next is this code. This this code is mean that uh, this create a new image to store the result blending with the RGBA mode. Oh, this code. Uh, this will be uh, multiply the scalar c uh, x y equals a xy multiply by alpha. Okay, for the last for the this code is mean that create a new image to store the result of the blending with the RGBA mode, and this this code it insert the pixel data of the blending result into the new image, and this code is the for the convert the blend image into the upper color depth if necessary. And this is the function return the blend image that modify according to input of power factor. Okay, moving on, the scale zoom out. In this code, uh, in this code, in this code, this means that this gets the width and height of the input image, and this code is the for calculate the number of row and columns in the output image after zooming out by a factor of n. This is obtained by defining the width and height of the input image by the scale factor. Moving on this code. This code is the main this creates an output image with a pre-calculated size which will be used to store the zoom out result. Okay. Moving on this code. On this code, this is for the loop. This is will iterate through its row in the output image. Okay, moving on this code. This means this rectifies the pixel value of the input image by taking every nth pixel in the H directory, such as row and column, to obtain the zoom out result. Moving on this code, this means that the puts the pixel value extracted from the input image into the output image at the corresponding position after zooming out. This is the for the little image that has been modified according to scale factor and for the zooming out. And for the last code in the processing list is the zoom in. Same with zoom out code. I just change the this code. I just change the value of this code. This rectifies the pixel value of the input image by defining its coordinate g and I by the scale factor n to obtain zoom in result. This puts the pixel value that have been extracted from the input image into the output image at the corresponding position after zooming in. Okay, maybe that's it for the demonstration. PySimpleGui for the digital image processing.